The inkjet printer is a genius invention. Unfortunately, this device is still monopolized by the US and Japan. If we zoom in on a printed photo, we can see that the photo is made up of the last ink drop. Not only that, but the printer can print millions of colors with only 4 types of ink. What's the magic principle? It's all in the printhead. The printhead has a large number of nozzles. Each nozzle is thinner than a hair. The nozzles are designed to be wide at the top and narrow at the bottom, which creates a negative pressure that prevents the ink from leaking. And once you start printing, a heating resistor on top heats up to 100 degrees in 1/1000,000th of a second. The high temperature vaporizes the nearby ink and creates air bubbles. The bubbles act as a piston to push the ink out from underneath. The pushed droplets form a main droplet and a trailing droplet due to their viscosity. They fall at a speed of 10 meters per second. The nozzle is 1 millimeter away from the paper, so it takes only 1/10,000th of a second to reach it, and is absorbed by the paper in a fraction of a second. The printhead is connected to the printer by a hose, and a stepper motor drives a belt and pulley to move the printhead, and a shaft stepper to move the paper. This is the basic structure of the printer. So how do you print colorful photos with 4 types of ink? You might think of mixing red, green, and blue. Let's do a little experiment first. If you use the red and green flashlight add up, the mixture is yellow, but if you use red and green ink mixed to get a very cloudy yellow. In fact, this is the difference between additive color mixing and subtractive color mixing. For self-luminous color light, mixing the 2 colors will increase the brightness of light, but the ink itself doesn't emit light. We can see the color of the ink because the optical fiber hits the ink and reflects back to the human eye. This process filters out some of the color. To better understand this, we've zoomed in on the droplets to get a microscopic view. If the green molecules in the lower layer want to reflect the green light, they have to penetrate the green molecules in the upper layer and the red molecules. But this process is blocked by the red molecules and creates a black color in that area. The same way, the lower red molecules are blocked by the upper green molecules and create a black color. This is what causes the yellow color to become cloudy. To give you a common example, the gray hair that we see with our eyes is actually a mixture of white and black hair, so it's clear that the primary colors of red, green, and blue can't be used directly in printers. The solution is very simple. Simply replace red, green, and blue with the complementary colors cyan, magenta, and yellow. When the nozzle releases a drop of cyan and then quickly releases a drop of yellow, the two are mixed together to create a mesmerizing green color. And the diameter of the blended drop is only 0.05 millimeters. This way you can get a wide range of colors. What if I want a lighter green color? You can get a lighter green by increasing the distance between the drops, and the other way around you get a darker color. But there's always a limit to how far apart you can go. What if I want a darker green? At this point, black ink comes in handy. Mixing black into a green droplet will give you a darker green. The more black you mix in, the darker the green will be. So if you use CMYB, you can print millions of colors, and an A4 size photo can even have hundreds of millions of ink droplets. We have to admire human intelligence.